All right, we're talking systems of equations in 3 variables today. That's probably x, y, and z for most of your assignments, all right? In this one, we have these 3 equations up here. We're going to try to figure out what x, y, and z is. Instead of a system of equations in 2 variables where our answer was an ordered pair, an x, y ordered pair, here it's actually going to be an ordered triple, x, y, z in those parentheses, okay? So let's try to do this one. It looks like in each of these I have 2 different letters. I have x and z, y and z, and then x and y. All right, so what I probably want to do is find one that has a 1 as its coefficient, and then maybe isolate that and then substitute that in for another one where I can figure out 2 variables and maybe go from there. All right, let's maybe show you what I mean by that. So I'm seeing kind of in this middle one, I have a y and a z. If I subtract the z over to the other side, like this, then this equation is now going to be y equals 5 minus z. Okay, so why does that help me? Why does that help me there? All right, what I can do is take what y equals and I can plug it back into the only other equation that has a y, which is this one. Okay, let's try that. And then if I sub it in there, now it's 11x plus, I'm gonna leave a space for what y equals. And then in that space, we can say 5 minus z. 5 minus z. I'll combine some like terms and see if anything can work out here. Let's see, 11x plus 5 minus z equals 15. Subtract 5 to the other side. And let's see, I have 11x minus z equals 10. All right, so it doesn't really look like this got me any closer, but it actually did, okay? It actually did, because the only equation I haven't worked with yet is this top one, which also has an x and a z. This one has an x and a z, so now I can actually solve this like I did with normal 2-step system of equations. So I'm gonna rewrite this one. All right, so what I did there is I rewrote my top one with the x and the z and the one that I used with the y to kind of sub in down here with my x and z. And now, since I have just an x and a z, I can probably use elimination to solve these, all right? Looks like I can take maybe this top one times a -1, and that should cancel my z's. So if I do that here, this is now -8x plus z equals -4. And if I combine those 2 bottom ones together, this is gonna be 3x. Those cancel, which is good. And then 10 minus 4, of course, is 6. If I divide both sides by 3, x equals 2. Perfect, I got one of my 3 variables. I got x. Let's maybe try to find another one. So what I could do is sub this right back in to one of the ones that had just the x and the z. I kind of like this one down here personally. So let's sub that in. And now it's going to be 11. Instead of x, I can replace that with 2 minus z equals 10. 11 times 2 is 22. 22 minus z equals 10. And let's see, on this one I would how about subtract 22 to both sides. And this gives me, I have to come up here, negative z equals, let's see, that'd be -12. -12. And if I divide by a -1, then z equals +12. All right, so I have x and I have z, which now means I need to sub something back in, probably to this one with the y, to figure out what y is. And if I do that here, this would now be y. Instead of plus z, we can leave a space for z and put 12 equals 5. And for this one, I just have to subtract 12 to the other side. Those cancel, and y equals a -7. So the answer again is my x, y, z triple. So I have x as 2, y is -7, z is 12, or my answer 2, -7, 12 as an x, y, z triple.